Hello guys, in our previous session we have seen basics of CAN protocol. Now we will see features of CAN. Okay, so coming to first point, so CAN is two-wire communication protocol, which means in CAN protocol we will use two wires. Okay, one is CAN high and CAN low, and these two wires are twisted pair, like we will twist those pairs. Okay, I will show you like what is twisted pair. Okay, so coming to second point, it uses differential voltage method to transmit its data. So what does it mean? Why CAN protocol using differential voltage method? We will see it. So for example, consider guys, there is only one wire. Okay, if there is only one wire, what will happen? Okay, and why we are not using say single wire in CAN protocol, why we are going for two wires, and why we are going for this approach, differential method approach. Okay, I will explain everything in detail. Okay, first of all, consider, we will see what will happen if there is only a single wire in our CAN protocol. Okay, single wire. So consider, for example, I want to transmit logic means bit value, logic 0. Okay, I want to transmit logic 0 for transmitter to receiver. If I want to transmit logic 0, then I have to transmit 0 volts inside that wire. Okay, I want to transmit 0 volts, but we know that inside car there will be many ECUs and battery and some different electronic gadgets, like we have this infotainment related things, and different things will be there. Okay, inside that. So like in our school days we have studied that. So if any wire is within the flux, I mean within the magnetic flux, okay, due to that change in magnetic flux, there are chances of inducing a voltage inside that wire. Okay, we call it as electromagnetic interference. Okay, so in our car okay, there are chances of, due to that electromagnetic interference, voltage is being induced. Because of that, what will happen is, instead of 0 volts, voltage is getting induced inside that single wire, and for example, consider it became 3 volts. Then what will happen? The transmitter is wanted to transmit logic 0, which means 0 volts. Okay, but because of external things like EMI or external noise, okay, because of external noise, that 0 volts became 3 volts, like due to EMI, we can consider like electromagnetic interference. Okay, so it became 3 volts. Now what the receiver will think? The receiver will think like the transmitter itself is transmitting 3 volts. Okay, and because of that, there are chances that receiver will consider these 3 volts as 1, logic 1. Okay, logic 1, but what the actual logic the transmitter wants to transmit 0, but what the receiver is thinking, it is getting 3 volts, so it is thinking that this should be value 1. Okay, what will happen here? The data is corrupted, data is manipulated, right? So the transmitter wants to transmit 0, logic 0, but the receiver is thinking it is logic 1. So it is not the thing, right? It should not work like that. Am I right? So because of this thing, okay, so this is the issue if we are using a single wire. Okay, to overcome this, so this CAN protocol was designed with two wire. Okay, it was designed with two wire. So what is the advantage of having this two wire, and why they are going for differential voltage? Okay, we will see it. We are using two wire because the difference between these two wires, means there is a voltage in one wire and there is some different voltage in and another wire also, means in these two wires we have two different voltages. Okay, the difference between these two voltages will give you the which value you want to transmit, means will give you the value which you are going to transmit. Okay, for example, consider like this is the actual scenario. Okay, if you want to transmit logic 1, okay, then in CAN high you want to transmit 2.5 volts, and in CAN low also you have to transmit 3.5 volts, and the voltage difference between these two should be 0 volts. Okay, if you want to transmit logic 1, okay, means if your transmitter is want to transmit 1 bit, I mean the value of the bit is 1, okay, then the voltage in CAN high wire and the voltage in CAN low wire should be this 2.5 and 2.5, okay, and the difference should be 0 volts. Okay, so at the receiver side, the receiver will receive this 2.5 volts in CAN high and 2.5 volts in CAN low, and it will do the difference of that voltage, and the difference is 0. Then the receiver will understand transmitter is transmitting logic 1. Okay, and the same with logic 0 also. So if the transmitter wants to transmit logic 0, then the transmitter has to keep 3.5 volts in CAN high and 1.5 volt in CAN low. Okay, so at the receiver side, the receiver will read this 3.5 from CAN high and 1.5 from this CAN low, and it will do the difference of these. And if the difference of these is 2 volts, then the receiver will think, okay, that logic 0 is transmitted. Okay, so this is the this is how they have implemented this CAN protocol. Okay, now for example, consider there is no any noise, no EMI, nothing. Okay, in CAN high wire we are transmitting some voltage, that is considered as V high. Okay, in CAN low wire also we are transmitting some voltage. Okay, consider that as V low. Okay, so the difference between this CAN high and CAN low is nothing but V high minus V low. Okay, this is some voltage we are getting here. Okay, if there is no external noise impacted on this bus, okay, this is how it is. For example, means this is the resultant, the difference. For example, consider due to some external things, okay, some noise was impacted on the bus, which means due to EMI or noise, some voltage was induced. Okay, some voltage was induced in the wire. Okay, now that voltage will become, so in CAN high the total voltage will become the voltage which transmitter wants to transmit plus this extra noise voltages, I mean extra noise voltage induced, okay, because of this external things. Okay, now in CAN high it contains the total voltage as this one, high voltage which transmitter wants to transmit plus extra noise voltage. This is the unwanted voltage, okay, that is getting induced in the wire. Similarly in CAN low also, this is the low voltage which transmitter is willing to transmit, and this is the noise voltage got induced due to external events, external things. Okay, so now if you at the receiver side, the receiver will do the difference between the voltage CAN high minus CAN low. Okay, in CAN high wire we have, this is the voltage we have in CAN high wire, and this is the voltage we have in CAN low wire. Okay, so the difference between CAN high and CAN low will give you high voltage minus low, which is nothing but this voltage and this voltage both will be same. Okay, so because of this noise, even though some extra voltage is getting induced in our wire, because of differential voltage method we are using, that extra noise voltage get cancelled at the receiver side. Okay, so that the resultant will not vary. Okay, the resultant will not vary. Okay, we will come with an example here. For example, consider we will see the both scenarios. For example, consider I want to transmit logic 1. I want to transmit logic 1. Okay, so if I want to transmit logic 1 in CAN high, I want to put 2.5 volts, correct? And in CAN low also, consider this is can high. In can high I am putting 2.5 volts. Okay, and in can low also I am putting 2.5 volts. Okay, so what will be the difference? 2.5 minus 2.5, so the resultant will be 0 volts. Okay, so if no external impact, nothing, if no noise, nothing is impacted, then we are getting 0 volts at the receiver side when we are transmitting 2.5 and 2.5 in can high and can low. Okay, which is nothing but it will understand logic 1 is transmitted. Okay, this is how it will think. For example, coming to this scenario, in can high same I am transmitting 2.5 volts. Okay, due to noise, for example, consider 1 volt extra is getting induced, means I want to transmit, transmitter will transmit only 2.5 volts. Okay, but because of external noise 1 volt got induced. Okay, so the resultant became 3.5 volts. Okay, in can low also transmitter is transmitting 2.5 volts only, but extra 1 volt was got induced. Okay, induced because of this noise and all. So in can low also the resultant became 3.5 volts. So if we do the differential voltage now, so 3.5 volts minus 3.5 volts will give the resultant 0 volts. Okay, which means there is no difference here. Okay, so the output will not vary, will not change, even though there is any voltage induced because of external things. So this is the advantage of differential voltage. The extra noise which is getting induced will get cancelled because the same amount of noise is inducing in both can high and can low. Okay, now you can ask me, like, why we are considering same voltage, same noise? What if some different, for example, here 1 volt got induced and here 2 volts got induced, 2 volts, then there are chances, right? We cannot say definitely every time the can high whatever the voltage getting into the same amount also will get induced in can low. No, here the CAN protocol was designed in such a way that the same amount of voltage will be induced in both the wires. Okay, then you can ask me, like, how can you justify it? How can you decide the same amount of voltage will be induced in both? So to make sure the same amount of voltage has to be induced in the both wires, we came up this twisted pair. Why we are using twisted pair here? Because you can see every point, at every point, so you have both wires twisted. Okay, which means, for example, consider this point. So here whatever the magnetic flux affecting, it will affect both the wires in same way, so that the same voltage getting induced in both the wires. It's not like two different wires at two different locations or do different points. At any point the both wires will get same impact. Okay, because they are twisted that closely. So now you got clarity, right? Because we have this twisted pair, the same amount of noise will be induced in both the wires. So this is the purpose of using twisted pair. Without twisted pair, we cannot say the same amount of noise will be induced in both the wires. There might be a difference. Then we cannot decide how much is induced in this wire, how much is induced in this wire. We cannot say it. If both the noise are same, then only we can say, like, the difference will give the exact accurate value. Okay, to match both values with same voltage level, same noise voltages, so we are using this twisted pair. Okay, so because of that twisted pairs, this noise amount voltage will be same, and because of this differential method, whatever the noise getting induced, that will not impact your voltages, because we are using the difference here. Okay, I hope you got it. Okay, that is the purpose of using differential voltage. Okay, and coming to third point, it contains line terminating resistors to avoid reflections of the signal at the end of the wire. So what does it mean? So in our previous class we have seen that here only. So here we have seen that, so at the end of the bus or at the end of the wire we are using a 120 ohm resistor. Like, what is the purpose of this resistor is, for example, in this wire some voltage, for example this is the wire. So in this wire some voltage it is traveling, some voltage is going. So the voltage from, this is the transmitter side, this is the receiver side, so the voltage is transmitting in this wire. Okay, it reaches this receiver side. Okay, and the node is reading the voltage value. Okay, it is not using that voltage, means whenever some voltage is present in the wire, some load should be there to absorb that voltage. Am I right? If there is no load to absorb that voltage, then that voltage will be present in the wire only. Okay, someone has to use it, that voltage has to be used somewhere. Am I right? So that load is nothing but this resistor. So this resistor will absorb, for example, consider guys, this ECU is transmitting some voltage in the wire. It will reach till the end of the wire. Okay, at the end this resistor will absorb that voltage. Okay, now you can ask me, like, what will happen if that voltage is not absorbed? What impact it will create? What will happen is, if there is no resistor here, then at this end of the wire that voltage will, the voltage is nothing but that voltage signals, that signal will reach the end of the wire, and at the end it will reflect. It will reflect and it will start to transmit in the reverse order, in the reverse direction. Okay, so what will happen at the time, if for example this ECU1 is transmitting 2.5 volts first time. Okay, so it reached till here. Okay, in the next second, in the next time, this ECU is transmitting again some 2.5 volts only. Okay, so now this 2.5 volts is traveling here, and the first 2.5 volts is reached here, and it will reflected back, and it is coming in the backward direction. And the second time transmitted 2.5 volts will come here, and the both will they will intersect or collide or something like that. Okay, because of that what will happen is that voltage levels will vary. Okay, because of that thing, for example this ECU4 has to read the voltage level here. So this first 2.5 is reflected back, and second 2.5 volts is both are merging here, and the voltage is changed here. Then what will happen, this ECU4 will read different voltage other than 2.5. Okay, that is not the similar. Because of this thing also there are chance of corrupting the data will be corrupted. So to avoid this thing, we are using a 120 ohm resistor here. That resistor will absorb the voltage. Okay, and it will avoid to reflect that voltage back again. That is the purpose of this 120 ohms. That's why this 120 ohms is present on both ends of the bus. Okay, now you can ask me, like, how you decided this 120 ohms? Guys, this is a CAN protocol, which means a set of rules will be there. So this 120 ohms was given by the Bosch. Okay, they have tested and they have given 120 ohms. 120 ohms will accurately absorb that voltage which we are using in our CAN protocol. Okay, I hope it was clear. That is the third feature. It contains line terminating resistors. What is the purpose of these resistors? They are used to avoid the reflections of that signal at the end of the wire. That is the purpose of these resistors. Okay. And coming to fourth one, CAN protocol is half duplex, broadcast type, and asynchronous serial communication with MSB going first. So in our previous video we have seen what is half duplex, asynchronous and serial. Okay, if you have not checked that, you can check it. So it was discussed here in our previous video. Okay, so CAN protocol is a half duplex. Broadcast means this also discussed, like only one node will transmit, all the other nodes will receive at the same time. It's not like one-to-one communication, it's one-to-many communication. That is called broadcast type. Okay, and broadcast type and asynchronous serial communication with MSB going first. What is the meaning of this MSB going first? So in every byte we have LSB and MSB, means least significant bit and most significant, most significant byte and least significant byte. So the thing is, in every byte the MSB bit, for example, consider 1 0 0 0 1 0. So these are 8 bits. Okay, consider this is the least significant bit and this is the most significant bit. So if my transmitter wants to transmit this whole byte, then in this whole byte, so first this bit will be transmitted and again this bit will be transmitted, like that. First MSB will be transmitted. Okay, I will give you more clarity here. So consider, guys, for example, I want to transmit these 3 bytes of data. Okay, then how these 3 bytes of data will be transmitted? First, this is the LSB byte, means lowest significant byte. Okay, this is the most significant byte. Okay, so which one will transmit first? Means first this one will transmit this byte, the lowest significant byte, means the lower byte will transmit first. So in that lower byte also, usually what we will think, it will transmit this one first. No, in this lower byte also this bit will transmit first, most significant bit. This will be transmitted first. First 1 will be transmitted, then 0 will be transmitted, then 0, then 0, then 1, then 0 0 0, like this whole byte is transmitted. Then it will come to this byte again. In this byte again this one will transmit first, this 0. So this 0 will be transmitted first, and then this 0 0 1, and then 0 0 0 1. And if this byte is completed, then it will come to this third byte. In this third byte, this bit is transmitted first. Okay, this is how data is getting transmitted in CAN protocol. Okay, that is the meaning of that. Coming to 5th point, maximum speed of CAN is 1 Mbps. So guys, we already discussed in previous video that here it is a asynchronous serial communication, means it is a asynchronous communication, means here we don't have any clock line to transmit the data. Here we are using baud rate, which is nothing but like speed. So the maximum speed of CAN is 1 Mbps, means 1 megabits per second. Means in 1 second our CAN protocol can transmit 10 power 6 bits. Okay, so this is the maximum speed. Basically in industry, companies use either 500 kbps or 250 kbps depending on their requirement. Okay, and coming to 6th point, it supports message acceptance filtering, which means, for example, we know that now CAN is a broadcast type which means the transmitter is transmitting and all the receivers are receiving. For example, consider in this scenario, my ECU1 is transmitting the data and I have 3 other ECUs which are in receiving. Okay, whatever the data I am transmitting from ECU1, that data has to be received by ECU4. Okay, this ECU2 and ECU3, they don't need that data, only ECU4 has to require that data. Then what we can do is we can do filtering kind of thing. Okay, filtering only. we can do filtering, so that whatever the data you are transmitting on the bus, that data will not read by ECU2 and it will not read by ECU3. It will only read by ECU4. This kind of thing we can do in CAN protocol. Okay, you can ask me like what will happen if ECU2 and ECU3 also, if they read, let it read. Like what is the issue if it was read? The problem is, it's not a problem, but unnecessarily the load will increase here. This ECU2 and 3, they don't need the data. Then what is the purpose of reading it? What it will do with reading the data? They don't need it, right? Then why we need to read the data? We can discard it. So that is nothing but message acceptance filtering that can be done in CAN protocol. Okay, and coming to 7th point, it supports auto retransmission of frames that have lost arbitration or have been destroyed by errors during transmission, which means our CAN protocol supports auto retransmission of the frame. Okay, for example there is arbitration going on. Okay, so my node, guys, if you don't know about arbitration, it will be discussed in the next video, don't worry. Just consider, like, just listen to it. In next video you will get more clear. For example, this is my one ECU and this is ECU2, this is ECU1. At same time, this ECU1 and ECU2 wants to transmit its data. Okay, then what will happen? Then arbitration comes into picture. Among these two ECUs, which message is having high priority, that message will get the bus first. Okay, for example, in this scenario, consider ECU1 have high priority, ECU1 message have high priority, so that message is getting transmitted on the bus first. Then what will happen to this message which ECU2 is going to transmit? That will not transmit at that moment. Okay, once this ECU1 is transmitted its data completely, and when the bus is idle, then ECU2 will again transmit. Means for the first time it transmitted and it lost in arbitration. Okay, so in the next cycle, in the next time, so when the next time the bus is idle, then ECU2 will start to transmit its data. Okay, automatically. Our CAN protocol is designed in such a way. If anyone lost in the arbitration, then in the next time they will again try for its transmission. Okay, that is one thing. And the same thing will also happen during errors. For example, during your data transmission, some error happened and that data frame was discarded. Okay, then your node again will try to transmit the same data frame. If you are not getting this point, don't worry guys, in further classes we will see. Okay, so these are some of the features supported by the CAN protocol. Okay, so these are the mainly need to know. Okay, some other things will be there, like those are not that important, and if you are important also, like they will be covered, like while discussing the topics you will get to know. Okay, I think it's clear guys. Like in the next video we will see like arbitration, bit stuffing, and we will slowly go like what is we will see all the data frames. Okay, error mechanisms and errors, types of errors, what is bus of everything including the CRC collection, everything we will discuss. Okay guys, I hope it's clear. Okay, thank you.